want to go. All right, so we're going to move around this differential equation until we get 1 over 1 minus y squared equals 2x dx. We're then going to put in our limits, like so. And we're going to have a 0 for x, 1 for y. And then we're going to have y on, that's a dy, so that's going to be a y on top and an x on top. Now, what do you reckon the derivative of the yellow one is? We sort of did it earlier today. Sine y? Sorry, sine inverse y? Yeah. Sine inverse y. And that's from y1. And then integrate that. Would you all agree with x squared? Because we differentiate x squared turns back into 2x, and that's from x to 0. And in a way, this might be slightly disappointing now because it's going to be sine inverse y minus sine inverse 1. What is sine inverse 1? You'd never use degrees though. Pi over 2 in radians, yeah. And plus x squared over your side. Sine inverse y is x squared plus pi over 2. This means y is what, guys? Sine x squared plus pi over 2. Our next question is ds dt plus sine t over s equals 0. Now for me, my s's look like 5s and my t's look like pluses. So there's nothing wrong with using a capital T and try and make the letter S much smaller than any numbers you're using. Okay, so S equals root 2 when X equals pi over 3, or sorry, T equals pi over 3. There we go. Hop in here, which is yes to T is minus sine T all over S, cross multiply. We're going to get a SDS equals sine T to T. I'll take the sign outside the, I'll take the minus outside the integral. And I'll integrate both sides with regards root 2 and S and T and pi over 3. Well, I'm going to integrate sine T. So double negative cos T, yeah? Double negative cos T is just cos T. And T and pi over 3. Integrate S and you get S squared from S and root 2. S squared over 2, thank you very much. Now, plug it in and we get S squared over 2. Take away root 2 squared all over 2, which we all know is the number 1. Okay, number 1. And then we should get cos T minus cos pi over 3. Cos pi over 3 is actually a half, isn't it? Good. And then I could bring over the minus 1 and it'll turn the whole thing into a plus a half. Multiply everything by 2. Square root it. Did anybody get this? Y doesn't have both the plus or the minus in the answer. So let's go back to the two limits we're given. What were the two limits again? Pi over 3 when, sorry, S equals root 2 when T equals pi over 3. Let's think about this. Let's put in 2 cos pi over 3 plus 1. And the answer would be root 2. So that automatically rules out the limits rule out the negative answer. So there's only ever going to be the positive one, and you only have to write down the positive one. So you can use your limits to maybe eliminate one of the answers if it's a square root question. Is that all right? So just be aware of that. Dy dx equals cos x over y means 1 over y to y. Oh, I'm wrong. It's y to y equals cos x dx, and integrate pi over 2 y or 1. They're both positive, aren't they? At the same time. And then that'll be y and x. Integrate. We get a y squared over 2 from y and 1. And then we should get a, what happens when you integrate cos x? Just sin x, is it? Okay. And it's x to pi over 2. And then we're going to get a y squared over 2 minus 1 squared over 2, which is a half. And then equals sine x minus sine pi over 2. And what do we know about sine pi over 2? Integrates 1. Bring it over to minus a half, and what happens? It becomes plus a half. And then you should get sine x minus a half equals y squared over 2. Cross multiply up to 2. And you get a 2 sine x take away 1 is y squared. Square root it. Why do I only need to worry about the positive one and not the negative one again? Why is it not plus or minus this time? When y is positive, x is also positive. So you know it's just a positive answer this time around. Okay, and you're done. So turn e to the x, take away y. Turn that into e to the x and e to the minus y. And then when you bring up to the dx, it's going to be e to the x dx. And then the other one is going to be 1 over e to the minus y to y. Does anybody know what 1 over e to the minus y actually is? It's 1 over 1 e to the y. Bring it up, turn it upside down. E to the y. Yeah. All right, you guys finish that off now. It should be good to go. And when you integrate e to the y, you also get e to the y. So you have e to the y from y to ln4. Then you have e to the y minus e to the ln4. Now the weird thing about e ln4 is if you put that into your calculator, what do you get? 4. It's like an undo button to the opposite of each other, so it's like it's inverse, so it just turns into 4. And then that'll be e to the x, and it's x and 0, so it's e to the x, take away e to 0. We all know e to 0 is the number 1. And then bring it over to your side, and we get e to the y is e to the x plus 3. Now, the problem is y is in the power position. How do you get rid of that? Anybody remember? ln both sides. Remember your ln the e, the x, and the 3. Bring the y to the front, and you get y ln e. And what is ln e? 1. And you just get e. Yeah, you have your answer now. That's it. I'll jump in behind here. Okay. 2 dy dx ends up to be, I'm going to factorize out x into y plus 1. Then I'm going to get 2 times, actually I'm going to bring the 2 over, it'll just be fair to do that. I'm going to bring the y plus 1 down, so it's going to be 1 over y plus 1 get a half x on this side. Alright? Then I'm going to integrate it from 1 and 2, y and x. Now, don't get me wrong, you could go direct here. Do you see my top limit for x? You could actually just say that x equals 2. You could do from 2 to 1. I never really do it that way. I always do it the general way, and then I'll sub it in later. But that's up to you. It could be faster, to be fair to it. All right. Did anybody get ln y plus 1 from y to 2? And then I'm going to get a half x minus a half. Do you know what I'm thinking here? I'm thinking actually just putting in the 2 is much faster. So 2, 1 take away a half is what? Half, isn't it? So I'm going to do it this way instead. It seems a lot faster, to be fair to it. Is everybody happy enough with what I did with the, it doesn't ask me for the generalized equation, it just asks me for the value when x equals 2. So that's why I used that on the top limit. It's going to come out a lot faster. So time's important. Plus 1 minus ln 3, and then ln y plus 1 is a half plus ln 3. And then we're going to do that e thing, aren't we? Yeah. Y plus 1 is e to the power of a half plus ln 3. And then bring the 1 over the other side. Y equals e to the power of a half plus ln 3. Take away 1. Somebody be so kind as to throw all that into the calculator for me. Huh? Did I go wrong somewhere? I should get 5.35. Actually, I'm made a mistake further up here, guys. So the left-hand side is perfect. The right-hand side is, don't know what happened there. Alright, just appears I'm doing the whole thing again. Alright, so I actually never integrated the right-hand side. I went straight into limits rather than actually integrating it. So if I'm going to integrate half of x squared over 4 exactly. That's where I messed up. And it should be 2 squared over 4 minus 1 squared over 4. Would you all agree that's 3/4? So 1 take away a quarter, which is 3/4. It's my bad. And then we're still doing the ln y plus 1 minus ln 2 plus 1, which is 3. And then what we're saying here is it's 3/4 plus ln 3 is ln y plus 1. And the maths we did earlier is still alright. It's to the power of a. So it's e to the power of 3/4 plus ln 3 is y plus 1. Swing the 1 over the other side and take it away. Somebody be so kind as to put that in the calculator and tell me what you get. 5 points.